Hello, hello, hello. I hope you had a wonderful couple of days off last week for the holiday and time for yourself or with family or with friends or whatever it is that you chose to use on that long weekend that many of us had. I hope it was great. And in general, I hope the summer is treating you well. So I am getting ready to actually go on my vacation. Super excited to go with my kids. I'll send some pictures, I promise. But I wanted to kind of jump in quickly today and talk about something that has come up a bunch over the last couple of weeks. And, just in general, it comes up often as we're thinking about how do we help our students see the pattern in our data and think in the aggregate rather than for like individual values of the data. And once we learn how to calculate an average, I am seeing this in real time with my fifth grader. It's this very tantalizing thing of like, oh, we can take so many numbers and we can reduce it down into a number. And then we can use that number to look at our data and talk about it and things like that. Averages are great in certain situations. So if you've joined me in the data literacy bootcamp, or if you want to come join us, we're going to be talking about this later in July as one of the many things to think about kind of how we help our students make better sense of their data, identify the evidence, really think about that claim and how it is based in that evidence that we have from our data, and then the like holy grail of the reasoning for how those evidence pieces lead to our claim. Or if you're not using claims evidence reasoning, how the evidence in our data and our reasoning, our understanding of it, are making sense, making meaning of it, pulls together into our conclusion. A lot of that comes to needing to think about our data overall. So thinking about it in the aggregate for the group. And almost all of what we do when we are looking at data from about fifth grade on is dependent upon us looking at the data overall and thinking about it as a sample. So lots of different layers here. As I say, we jump into it in the data literacy bootcamp. So come join us. We still have got a few spots. We would love to have you join us at the end of the month. But this average piece and thinking about the average piece shows up a lot. And I just wanted to kind of jump in here because while many of us, and oh my goodness, I say this all the time. I said this all the time through my 5th to 9th grade students. And I say this all the time with the undergrads that I work with now. It's like, you can't have a naked number. I say this with my children too, because, that's just how we roll in my household. So a lot of us have like that part of our vocabulary. Like we can't have a naked number. It has to have units. And I would like to broaden that to be like, we can't have a naked average either. We need to know what went into that average. So what am I talking about? Let's think about this a little bit more deeply. Does that gonna work? No. Let's go with this one. Okay. So great data set out of Data Classroom about cicadas. Some of us are living in the cacophony of cicadas at the moment. My heart goes out to you. I was there in, oh my gosh, what was that? Oh, that was the pandemic. That was like 2021, living in New Jersey with all of those cicadas. And it was just one brood that was coming out, one 17-year brood. So I can't even imagine the overlapping for you all in the Midwest right now. Okay, so Data Classroom has this great data set of cicadas, head widths. So we can think about it of like, okay, so do females have bigger heads, wider heads than males? So there are tons and tons and tons of data points in this data set. So an easy thing that we can do, and what we often see, is we can take all of those data across the two groups, male, female, and we can take an average. Now, very often for our students or for my students, they didn't have hundreds of data points per group or category, but they would have maybe 3, right? They'd taken 3 measurements of each treatment or of each category. And then they would often average it. I did this all the time. I told my students to do this back when I was in the classroom. Sorry, all of you past students. Hopefully you've learned the lessons. You learn the lessons better from people down the pipeline from me. But let's step back and think about where that leads us. So if we take averages, so we're going to take an average of the head width for the females, and that's going to be our bar height here. And then we're going to take an average of the head width for males, and that's going to be our bar height here. So, okay, then we've basically taken lots of data on all of our different samples, even if that lots of data are just 3 data points for each category. 3 is more than 1, and we've reduced it down to 1. So what we've in essence done is we've taken that natural, nuanced, all of those pieces, and we have collapsed it down to 1 number. So then really what our eye is drawn to is this bar higher than that bar? That's the way our eye goes. There's nothing wrong with that, except for the fact that this is where it gets a little tricky. We don't know just by these bars of averages how spread out our data points are. And if our data points are super spread out on both of these, for both of these categories, and in fact, there's like lots of potential overlap, that is going to influence what conclusion, what claim we're going to draw in terms of, do female cicadas have wider heads than males? Because it could be an artifact of our sample size if there's tons and tons of overlap. And what's challenging is that nuance of, oh, how much overlap is there? Does it really seem like in general female cicadas have wider heads than male cicadas? Then we either, one, need more data. Okay, we could always have more data. We're always looking at a sample. But it limits what we can say even from the data we have, because we're reduced down just to 2 numbers. And then this sort of draws us into this illusion of making very like black, white, deterministic statements of like females have wider heads. But so whole host of things going on here in terms of statistical thinking and variability and aggregate thinking and all of these things. But let me get back, let me focus in on this naked average, because we have taken an average and we have no sense of what the data are that went into this. So there are a couple of things we could do. We could, again, make bar charts of the average heights, but we could indicate some indication of the variability of our data. So for our older students, for our high school students, this could be great. They can calculate standard deviation, standard error, 95% confidence intervals, or they could use graphing programs like Data Classroom, Tuva, CodeApp, things like this. Even Google Sheets can calculate for them, with the one caveat that Google Sheets defaults to 1 as the value. You have to click an extra button for it to get based on your data for these error bars to be included in here. And now we at least visually have an indication of, okay, where are the data that are going into that average? That's giving us more pieces of evidence, more information about our data that we can pull from for that claim. Even better, and especially for our middle school students who love to take average, they're getting good at they're practicing calculating that mean, having them either, 1, plot all the data. This is the default in our interactive graphing programs. So Data Classroom does it as a jitter, CodeApp, Tuva do it as dot plots. So we could plot all the data. We could make a box and whiskers plot. They are learning this in our middle school math. This is giving us so much information. This is actually, as a reminder, the median. So our center line here in the box plot is the median, not the mean, though that gives us a lot more information about the data overall, because now we're starting to see, okay, so this is the median value for females. This is the median value for males. This is where most of the males recorded were, most of the females recorded. Yes, there's a pretty wide range, but the range is in general higher for the females and lower for the males. Do you see how many more pieces of evidence we have from our data set that can factor into our claim? All because we moved away from a naked average and we moved into either just not leaving it as a naked average and giving some sort of indication of the variability, or even more detailed, not even really using the average at all and using a way to visualize the data that gives us a lot more information about what we're looking at. Okay, that was an awful lot of me talking about a variety of different things. If any of those sort of piqued your interest, if you have questions, reach out. But more importantly, we're going to be diving into all of those more at the Data Literacy Bootcamp, July 29th through 31st. Would love to see you there. If it's of interest to you, reach out. I'll put the link in the chat here or the comments, whatever we say when we're going live, to provide some more information about it. But remember, think about it. Every time we have an average, we are taking away information. So we are taking away nuance, details, and pieces of lines of evidence for our students to look at and make sense of those data. I hope you have a wonderful rest of your day and try to stay cool. It's super hot where I am. I hope you are staying cool. With that, I'll see you next week on the other side of my vacation.